Okay, so we are talking about the subnetting, that subnetting in the classless addressing. So we know that in the classful addressing, we have the five classes: class A, class B, class C, class D, and class C. So if you want to perform the subnetting in the classful addressing, we need to consider the specific size of your network. For example, class A, you have a 8-bit of network ID and 24-bit of host ID. Okay, for class B, you have 16-bit of network ID and 16-bit of host ID. Suppose we are performing the subnetting in the class B, then we need to consider the size of the network, that is 65535. Okay, the size of the network is 65535, and then we can divide that network into the various sub networks. Okay, while in case of the classless addressing, we should consider that uh, the total number of addresses, okay, while network mask and the assigned number of addresses to each sub network, that is n sub, and also the subnet mask n sub. Okay, so we can say that the number of addresses, we should consider the four types of rules when we are performing the subnetting in the classless addressing. Okay, the first condition is the number of addresses in sub network should be a power of 2. Okay, so when we are considering that if we have the requirement of 120 addresses, then we should allocate total 128 addresses. Okay, the first condition is the number of addresses in sub network should be a power of 2. The second condition is where we are talking about the subnetting, we should consider the subnet mask for each subnetwork. Okay, so the subnet mask for each subnetwork should be found using the formula, that is n sub equal to 32 minus log capital N sub base 2. With this capital N indicate that the total number of addresses in particular subnetwork. We will see one example, so your idea will be clear. Okay, the starting address in sub network should be divisible by the number of addresses in that sub network. That is the condition that we have seen for the classful addressing also. Okay, that the starting addresses in each sub network should be divisible by the total number of addresses in that sub network. Okay, so the starting address છે એનું decimal value કાઢવાનું આપણે, and that should be divisible by the number of addresses, total number of addresses in that sub network. Okay, and always start the assignment from the larger blocks. ફોર એક્ઝામ્પલ એકની રિક્વાયરમેન્ટ છે 10 એડ્રેસની, બીજાની રિક્વાયરમેન્ટ છે 60 એડ્રેસની, અને ત્રીજાની રિક્વાયરમેન્ટ છે 120 એડ્રેસની. So we should start the allotment from the larger address block, that is 120 addresses. Okay, we will see one example so that idea will be clear. Okay, so more levels of hierarchy can be created using subnetting. Okay, for example, an organization that is granted a range of addresses may divide the range into several sub-ranges and assign each sub-range to sub-network. Okay, for example, let's say કે આપણે જે રીતે જોયેલું, let's say કે સ્કૂલ ઓફ એન્જિનિયરિંગ ને 500 એડ્રેસ જોઈએ છે, ઓકે, સ્કૂલ ઓફ નર્સિંગ ને 250 એડ્રેસ જોઈએ છે, અને સ્કૂલ ઓફ let's say સ્કૂલ ઓફ મેનેજમેન્ટ ને ખાલી 50 એડ્રેસ જોઈએ છે. Okay, so our first condition is we should start the allotment from the larger address block. So first સ્કૂલ ઓફ એન્જિનિયરિંગ ને allotment થશે, પછી સ્કૂલ ઓફ સાયન્સ ને, અને પછી સ્કૂલ ઓફ મેનેજમેન્ટ ને. Okay, then another thing is school of engineering can also divide that address block into the various sub blocks. Okay, for example, the 500 school of engineering allotment thela છે, that can again be divided into various sub network. For example, 100 for building number A, 200 for building number B, and let's say 200 for building number C. Okay, so this type of subnetting can be possible. These are known as the subnetting. Okay, so any level of hierarchy can be created, and for that, this type of, when we are creating the various sub network, then also these 4 rules must be satisfied. Okay, a 4 rules to satisfy થવા જોઈએ. And the first condition is number of addresses in sub network should be a power of 2. Okay, for example, આપણે 10 ની રિક્વાયરમેન્ટ હોય તો પણ આપણે 16 એડ્રેસનો એક બ્લોક એસાઇન કરવા પડે. ઓકે, 30 ની રિક્વાયરમેન્ટ છે તો પણ 32 એડ્રેસનો એક બ્લોક એસાઇન કરવા પડે. 60 ની રિક્વાયરમેન્ટ છે તો 64 નો એડ્રેસ એલોકેટ કરવા પડે. ઓકે, 120 ની રિક્વાયરમેન્ટ છે તો 128 નો બ્લોક એલોકેટ કરવા પડે. That means the total number of addresses in block must be a power of 2. The second condition is the subnet mask, that we will see by example. The third condition is starting address must be divisible by total number of addresses. And the fourth condition is always start the assignment from the larger blocks. Okay, જે મોટા મોટા બ્લોક આપણને જોઈએ છે ત્યાંથી અસાઇનમેન્ટ આપણે સ્ટાર્ટ કરવાનું. So here we'll see our example. An organization is granted a block of addresses with the beginning address 14.24.74.0/24. Okay, આપણને એક એડ્રેસ અસાઇન થયું છે that is 14.24.74.0/24. Okay, /24. So /24 indicate the mask of that block. So what it will indicate? जो આપણું mask है 24. So using this block we can create total how many addresses? Can anyone say that આપણને જે block assign થયો છે એનું mask છે આપણું 24. તો આ block નો use કરીને આપણે total કેટલા address create કરી શકીએ? Anyone? Using the mask of 24, we can create total how many addresses?
2 raised to 8.
2 raised to 8. Okay, 2 raised to 32 minus n. So we can say 2 raised to 32 minus 24. So 2 raised to 8. That is 256. Okay, 256. So our first address will be 14.24.74.0. And the last one will be 14.24.74.255. Okay. Then what we have to do is we need to divide this total 256 addresses into the 3 blocks. Okay, the first sub block has requirement of 10 address, second sub block has requirement of 60 address, and the third sub block has requirement of 120 addresses. Okay, so for example, let's say कि PPSU ने जे assign थयो छे, suppose this address is assigned, so in which we can say that School of Management require the 10 address, School of Nursing require the 60 address, and School of Engineering require the 120 address. Who is there? See, everything is going to be recorded. Okay, another option is I have a mobile phone that also I can keep as the recording mode and record all your activity and inform to the principal, sir. It may possible that your email ID is going to be blocked and in future you are not able to attend any of the lecture. Okay, so don't use any type of nuisance during the online lectures. Otherwise, it will be a great impact on your result as well as on your academics. Okay, so we can say that we have to divide this address block into the 3 sub-blocks. The first sub-block has requirement of 120, second has 60, and third one has the 10. So we need to design the sub-blocks by providing the range of addresses to these 3 sub-blocks. Okay. So for example, our first condition is we have to start our allotment from the larger blocks. Okay. The larger block is the 120 વાળો છે. એના પછી છે 60, and then after we have the 10. Just wait a minute. Okay, so our first address is the range of addresses 14.24.74.0, 14.24.74.0. Okay, and mask is 24. So we can say that the total number of addresses, as you have said, that 2 raised to 32 minus 24, 2 raised to 32 minus 24, that is 2 raised to 8, or we can say that 256. Okay, so our first address can be found by setting rightmost 32 minus 24. 32 minus 24 means rightmost 8 bit to 0. Rightmost 8 bit to 0, that will give you our first address. Okay, 74.12345678. The first address is 14.24.74.0. and our last address is 14.24.74. Setting the rightmost 8 bit to 1, that will give you the last address. Okay, so our last address will be 14.24.74.255. Okay, so we need to divide this into the three blocks. The one sub block of 10 address. Okay, the second one sub block of 60 addresses, and the one subblock of 120 addresses. One subblock of 120 addresses. Okay. So requirement is we have to start our subnetting from the larger block. તો આમાં larger block કયો છે તો 120 વાળો છે. તો પહેલા આપણું 120 ને assign થશે. Okay. Then the second allotment is for this 60 addresses. બીજો block 60 નો બનશે આપણો, and your third subblock will be of 10 addresses. Okay, so we'll start from the first block, that is one subblock of 120 addresses. Okay, so the number of addresses, our first condition is the number of addresses must be a power of 2. Okay, so અહીંયા આપણને 120 ની requirement છે. Then after we have to allocate total 128 addresses. We have to allocate total 128 addresses. So the total number of addresses will be 128. Total number of addresses will be 128. Okay, 120 requirement છે. Still we have to allocate total 128 addresses. Okay, the subnet mask for this subblock will be, so we can say that the subnet mask can be calculated using the formula, that is n1 equal to the formula is, we have seen 32 minus log n sub base 2. Okay, our formula is the subnet mask n1 equal to 32 minus log n sub base 2. So here our mask is /24, and here our mask is /24. That is the overall mask of this whole block. Now we need to consider the subnet mask of this particular subblock, that is of 128 addresses. Okay, so we can say that the subnet mask n1 is equal to 32 minus log 128. 32 minus log 128. So we can say that n1 is equal to 32 minus log 2 raised to 7, that is we can say the answer is 7. Log 2 raised to 7 base 2, the answer is 7. So the subnet mask for this first block is 25. The subnet mask for this first block is 25. Okay, so the first address of this block is, the first address equal to, the first address can be found by setting the rightmost how many bits. So setting the rightmost 7 bit to 0, that will give you the first address. So 14.24.17.0, that is our first address, and setting the rightmost 7 bit to 0, that will give you the first address. And the last address can be found by setting the rightmost 7 bit to 1. By setting the rightmost 7 bit to 1, that will give you the last address. The first address in this block is 14.24.74.0. Last address is 14.24.74.127. Okay, so total 128 addresses are going to be allocated, and the first address is 14.24.74.0, and the second address is 14.24.74.127. Okay, so the address assignment for the first subblock is complete. Okay, now we have to go for the second subblock. The second subblock is of 60 addresses. So the total number of addresses that we need to allot will be 64. Okay, the total number of allotted addresses must be a power of 2. So 16 requirement, still we have to allocate total 64 addresses. The subnet mask n2 will be 32 minus log, here we have the n sub. Okay, so here the number of addresses are The number of addresses for this block is log 64 base 2. Okay, so 64 base 2, that is 32 minus log 2 raised to 6 base 2. So value is 6. So n2 value is 26. N2 value is 26. So the first address will be, the first address in the block is, the first address can be found by setting the rightmost 6 bit to 0. The first address can be found by setting the rightmost 6 bit to 0. Okay, so here we can say that our address is completed at 127. Our address is completed at 127. Okay, so the new beginning address for this block is 128. New beginning address for this block is 128. Okay, so 128 can be 10, and we have the 60, 1 2 3 4 5 6. So this is our first address. The last address is, the last address is in this block. We have to fix this 2474 point is 10 is fixed, and by setting the rightmost 6 bit to 1, okay, 1 2 3 4 5 6, that will give you the last address of the second sub block. Okay, so the last address of the second block is 14.24.74.191. Okay, 74.191. So this is our second blocks last address. Okay, second block last address कयो बनता है आपको 14.24.74.191. Okay, now same process we have to repeat. Okay, so here we can say for this first block the mask is, subnet mask is /25. So here we need to indicate the subnet mask by writing slash notation. So /25/25. આના માટે છે આપણું સ્લેશ નોટેશન /26 અને /26. Okay, now આ બે બ્લોક નું કમ્પ્લીટ થઈ ગયું. Now we have to move to the third block. For the third block આપણને 10 ની રિક્વાયરમેન્ટ છે, તો કેટલા એલોકેટ કરવા પડશે આપણે? We need to allocate total 16 addresses. We need to allocate total 16 addresses. Okay, so the subnet mask value will be, 32 log, our total number of addresses are 16 for this block. 32 minus log 16. So n3 is equal to 32 minus log 2 raised to 4 base 2. So 4. Okay, so n3 value is 28. The subnet mask for this block is 28. The subnet mask for this block is 28. Okay, the first address can be found, the first address can be found by setting the rightmost કેટલા bit set કરવાનો, rightmost 4 bit to 0. Okay, so our address is completed at 192. So our last beginning address of this sub block is 192. Okay, so that is 14.24.74.11. Okay, so this 1100 and this rightmost 4 bit are 0, that will give you the first address. And the last address can be found by setting the rightmost 4 bit to 1. Rightmost 4 bit to 1, that will give you the last address. Okay, so by setting the rightmost 4 bit to 1, that is the last address of third subblock. So that address will be 14.24.74. This value is કેટલી થશે આપણી? 192 plus just wait a minute. This કેટલી થશે આની decimal value કેટલી થશે? So decimal value is 207. Decimal value is 207. So the last address of third subblock is 14.24.74.207. Okay, so by that way we can allocate the 3 block of addresses. Okay. The remaining remaining ક્યાં સુધી બાકી રહ્યા? The remaining addresses are from, so 207 સુધી allocate થઈ ગયું છે આપણું, તો 14.24.74.208 થી લઈને આપણા 14.24.74.255, ઓકે, આખા બ્લોકનું છેલ્લું એડ્રેસ છે આપણું 255. તો ત્યાં સુધીના એડ્રેસ આપણા બાકી રહ્યા છે, that we can allocate to some another sub network. Okay, the remaining addresses are from 208 to 255. Okay, total કેટલા બાકી રહેશે? તો total remaining addresses will be આપણે ટોટલ કેટલાનો બ્લોક છે? તો આખો બ્લોક છે આપણો 256 નો. ઓકે, એમાંથી આપણે કેટલાક એલોકેટ કર્યા? તો પહેલા માટે જે 120 હતું એના માટે આપણે 128 એલોકેટ કર્યા, 60 હતું એના માટે આપણે 64 એલોકેટ કર્યા, 10 માટે આપણે 16 એલોકેટ કર્યા. Remaining addresses will be 256 minus this value is 8 and 2. Okay, and it will be કેટલા બાકી રહે છે આપણા? Okay, so by performing this calculation we can say that the remaining addresses are, okay, so I have calculated in calc, so this value is 48. Remaining addresses are 48. Okay, so how we have performed? તો પહેલા તો આપણને એક બ્લોક એલોકેટ થયો હતો 256 એડ્રેસીસ નો. એમાં આપણને કીધું કે આપણી 3 રિક્વાયરમેન્ટ છે. એક બ્લોકમાં આપણે 120 જોઈએ છે, બીજામાં 60 જોઈએ છે અને ત્રીજામાં 10 જોઈએ છે. 120 માટે આપણે 128 એલોકેટ કર્યા, 60 માટે આપણે 64 એલોકેટ કર્યા, 10 માટે આપણે 16 એલોકેટ કર્યા. 128 એલોકેટ કરીએ, then your subnet mask is 25. Okay, 64 allocate करिए, then your subnet mask is 26. 16 allocate करिए, then your subnet mask is 28. Using that, we can find out the first address and last address. The first address of the first subblock is 14.24.74.0. The last address is 14.24.74.127. The subnet mask is 25. While for the second subblock, the first address is 14.24.74.128. The last address is 14.24.74.191. And the subnet mask is /26. Same for the third subblock, the first address is 14.24.74.192. And the subnet mask is /28. While the last address is 14.24.74.207. Subnet mask is /28. Okay. Now, if you have one more question, that the remaining addresses, okay, આટલા allocate કર્યા પછી કેટલા address બાકી રહ્યા? Then you can say that the last address is 207. Okay, so 208 થી લઈને 255 સુધીના address that are going to be remain. Okay, so that is 256. Okay, there are the total number of addresses for this whole block. Okay, so 256 માંથી we have allocated 128 plus 64 plus 16, so remainings are 48. So 48 addresses are going to be remain. Okay, so come back to our PPT. Okay. The first thing that we have found is the total number of addresses. 2 is to 32 minus 24, so 256. Okay. The first address is 74.0, last address is 74.255. Then we have started the assignment from larger to the smaller. Okay. For the 120, we have allocated the 128 addresses. The subnet mask is 25. This is the first address, last address. Second, for the 60 block, we allocated 64 addresses. The subnet mask is 26. This one is the first address, this one is the last address. For the third subblock, we have allocated 16 addresses. Subnet mask is 28, and the first address is /28. This one is the first address, this one is the last address. Okay, so total 20 addresses are going to be allocated. The remainings are 48. Okay, and his range is from 208 to 255. So here from this figure you can clearly see this allotment. Okay, so here we have the first subblock, that is of 128 addresses, second subblock of 64 addresses, the third subblock of 16 addresses. And this 48 are unused. Okay. The total number of addresses are 256 and the mask is 24. The subnet mask for subblock 1 is 25. For the second, the subnet mask is 26, and for the third, the subnet mask is 28. Okay. So this type of question can be asked. It can be a large question of 8 to 10 marks, and surely in your exam, one question will be there. Okay, for this type of question. So here I have provided you one exercise that you can perform at home. Okay, so we have given one block of addresses, that is 16.12.64.0/20. Okay, so our mask is 20, so we can have a size of the block. We can have size of the block, that means the total number of addresses will be 2 raised to 32 minus 20. So 2 raised to 32 minus 20 is 12. 2 raised to 12. So 2 raised to 12 indicates that 2 raised to 7 is 128, 2 raised to 8 256, 2 raised to 9 is 512, then 2 raised to 10 is 1024, 2048, and 4196. So the total number of addresses are 4196. That 4196 addresses you have to divide it into the total 8 blocks. And 8 block ma our requirement is of 256 addresses. Okay. So for example, suppose આપણને આ PPSU ને 8 block suppose આ block assign થયો છે, and then we have said that જે આપણી 8 school છે, જે 8 school ને we have to allocate total 56 addresses. Okay, so this type of distribution you have to create. Okay, so you can use the method that we have seen in this example, previous example, and you can apply here, and you can find out the range of this total 8 blocks. Okay, and finally also you have to find out the range of unallocated addresses. Okay, so just try to perform this exercise. If any doubt during solving, then you can ask at any time. Okay. Okay, then another thing is about the address aggregation. Okay, so what is the meaning of address aggregation? So it is said that the ISP, okay, so internet service provider, the first thing is who will provide this address. I have given this question in the last lecture, that you have to find out that who is providing these addresses. Okay, so if you came across the answer, you have came across one term, that is ICANN. ICANN, the full form is internet configuration. Internet configuration for something like numbers and okay, something like that. Okay, ICANN. You can search internet configuration authority for numbers and something like that. Okay, so this is a one authority, ICANN, that will provide you some set of addresses. Okay, so as individually assign karwana, that is not done by the ICANN, but ICANN kone provide kare set of addresses? So tamara ISP ne. So ISP is not only one authority. We have a local ISP. Okay, પહેલા આપણી નીચે આપણા local ISP હોય, એની ઉપર we have the national ISP, international ISP. Okay, like that. So the ICANN છે, that will provide you the set of addresses to that international ISP. International ISP એને જે block assign થયો છે એમાંથી જેના national ISP હોય એને provide કરે, national ISP આપણે જે local ISP હોય એને provide કરે, and finally you will get some set of addresses. Okay, it is not like that. When you are connected and you will get the IP addresses, that is one procedure by which you can get some set of addresses. Okay, so what is the meaning of address aggregation? So somehow we can say that the ISP can combine the various blocks to create one larger sub blocks. Okay, so here we have the 4 sub blocks, so in which the mask is 26, that in one block we have the 64 addresses. Second block we have the 64, third we have the 64, fourth we have the 64. Now one ISP has the requirement of total 256 addresses. સપોઝ આઈએસપી પાસે 64 ના 4 બ્લોક પડેલા છે અને આઈએસપી પાસે કોઈ એવું ઓર્ગેનાઇઝેશન આવે છે કે તેને 256 એડ્રેસની રિક્વાયરમેન્ટ છે. So what ISP will do, it will combine the 464 size block. It will combine 464 size block and it will allocate that 256 addresses block to that organizations. Okay, so once we have purchased this set of addresses from suppose PPSUA, ISP પાસેથી block purchase કર્યા છે, that is of 256 addresses. Okay, પછી who is the responsibility? So then it is the responsibility of this network administrator to provide we can say the configure the various machines based on that addresses. Okay, it is the responsibility of the network administrator. So either it can perform manually બધા મશીનમાં જઈને addresses નાખી શકે. Another option is DHCP. Okay, DHCP is not in our syllabus, but we will see some discussion about the DHCP, dynamic host configuration protocol. So this DHCP is using DHCP, you don't need to manual configure the every machines. You don't need to configure manually every machines. You can have a DHCP protocol configure and that can assign the IP address to the every devices. Okay, so that can be done that can be done automatically by using the DHCP protocol. Okay, so we will see that how DHCP is going to be work later when we have the completion of this module. Okay, so this is the thing how the addressings are going to be worked. Another thing is there are some special addresses. Okay, there are some special addresses that we cannot assign to any connection. The first address is 0.0.0.0/32. Okay, our પહેલું address. Okay, that is 0.0.0.0/32. So it is known as the this host address. Okay, so when it is going to be work. Okay, so for example, suppose whenever a host needs to send an IP datagram, suppose કોઈ source છે કંઈ પણ ડેટા મોકલવો છે and it is not knowing its own IP address. જ્યારે કોઈ હોસ્ટને પોતાનું જ IP address ખબર ના હોય, at that time it can set the source IP address as 0.0.0.0/32. Okay, so this is known as the this host address. Okay, the second thing is limited broadcast address, that is 255.255.255./32. That is all 32 bits are 1. Okay, so it is known as the limited broadcast address when we need to perform the broadcast within the network. Okay, suppose આપણા ડેસ્ટિનેશન આપણા નેટવર્કની અંદર જે બધા ડિવાઇસ છે અને કંઈ પણ ડેટા આપણે બ્રોડકાસ્ટ કરવો હોય, at that time in the destination address we can set this address. Okay, that is all four values are 255. Okay, so this data is received by all the devices within the network. Okay, network ની અંદર જેટલા પણ device છે that all will receive that data. But જ્યારે router પાસે data પહોંચે, router will see that the broadcast address is destination address is this one, so it will not forward that data into outside the network. That means જ્યારે આપણું destination address માં આ value set થયેલી હોય તો આપણો આ data network ની અંદર જ રહી, network ની અંદર જેટલા પણ device છે બધાને આ data મળી શકે. The third one is the private address. Okay, so એવા 4 block છે, that is 10.0.0.0/8, 172.16.0.0/12 and 192.168.0.0/16. Okay, these are known as the private addresses and their applications are in the NAT. NAT is a special topic that we will learn soon. Okay, NAT is network address translation. The meaning of NAT is within the network we have one common set of addresses, but જ્યારે આપણો data network ની બહાર જાય ત્યારે આપણને બીજું address assign થાય. So these are known as the private addresses. Okay, the fourth one is loopback address. Loopback address is 127.0.0.0/8. So loopback address ક્યારે use થાય? Okay, so for example, sometimes your own host is working as a source and your own host is working as a destination. For example, તમે કોઈ chatting application બનાવી છે, તમારા મશીનની અંદર તમે કોઈ chatting application બનાવી છે. Now તમે જે chatting application બનાવી છે એનું testing you want to perform. Okay, so you don't have any other PC, so what you can do, you can consider your own machine as source and your own machine as destinations. You can open the two different window. In one window the client messenger is working on, another window the server messenger is working on. Okay, and for that you need to set the destination address as 127.0.0/8. Okay, so when you are using this type of address as destination address, your own machine is working as a client and your own machine is working as a destinations. Okay, so these are some special addresses, this host address. Then we have the limited broadcast address, private address, and loopback address. Okay. Okay, so now we need to talk about the NAT network address translation that we will do in the next lecture, okay, that we'll learn in the next lecture. So that might be on the Thursday. Okay, so your Monday, Tuesday, Wednesday is Engineers Day celebration. Okay, so on the Thursday we will learn about the NAT, that is network address translation.